thanks so much. Hi, everybody. Thanks for joining us. Welcome to the talk. We're going to talk about building RESTful APIs with Spring. I want you to note, please, my contact coordinates up there at the top, at StarbucksMan on Twitter, and in particular my email. So if you have questions, it's josh.long@springsource.com. Do not hesitate to reach out to me. I'm always happy to hear from you and always happy to see if I can help. I'm the author of 4 different books now in Spring, and or lead author, I suppose I should say, and constant contributor and speaker about the technologies. A lot of people know about a lot of people know me from This Week in Spring, a roundup that we put together every Tuesday on springsource.org. It's a aggregation of the latest and greatest community content, tutorials, blogs, etc., as well as content from SpringSource about SpringSource, about Redis, about RabbitMQ, about Cloud Foundry. So why are we here? We're here to look at Spring's comprehensive REST stack. We'll look at it in terms of how to build a more sophisticated, more useful API, but we want to look at the application of the Spring stack for REST. REST, of course, is an architectural constraint originally proffered by Roy Fielding in his 2000 doctoral dissertation. It embraces wholly and completely HTTP, which is not all that surprising given that Roy Fielding was on the HTTP 1.1 standards committee. It's a style, not a standard. This is very important. There are some very dogmatic opinions about REST out there. I encourage you to err on the side of the angels and choose pragmatism over dogma. And we're going to try and be pragmatic here. One way of describing how compliant a RESTful API is with the REST constraint and the principles originally offered is through the Richardson maturity model. It's a very simple grading scale by which to judge a RESTful API. Martin Fowler has a great post that introduces a lot of the levels, but summarily there's level 0, the swamp of POCs, right? If you've ever used SOAP or XML-PC, then you are basically using a POCs service. These are typically services that use HTTP as a conduit or as a transport, but they ignore all the properties of HTTP and don't take advantage of the features there. They tend to channel everything through the transport, like through POST. In the case of SOAP, for example, HTTP is just incidental. You could use SOAP over JMX. It's just another transport. There's nothing native about it, and so as a result, it doesn't feel very natural on top of HTTP. When you get to level 1, you start to distinguish, nouns in the system or entities. You start to distinguish them and create different URLs for them. But basically, you're still treating it like RPC. This is in this case, this is kind of like XML-RPC. You can do better. And level 2 is where you start actually taking advantage of transport native properties like the HTTP verbs and HTTP status codes and headers and so on. And this is the level where you're going to be, if you just use Spring MVC's REST support out of the box, assuming nothing else today, you will be dumped at level 2. Okay, so you're already very far along the ladder here. You've got a pretty good story right out of the box. If you're using HTTP, of course, you should know there are many verbs. I've listed 4 here. These correspond to many people's notions of CRUD, but they don't map exactly to that, so that's very important to remember. HTTP GET can be used to retrieve the data or resource identified by a URI. HTTP delete can be used to signal that the resource represented by a URI should be deleted. HTTP post sends data to a server and to a URI, and then that URI has to do something with it. What it does is sort of up to the resource, right? It's up to the processing on the back end. Typically, it will create a new record and signal to the client where that new record lives through a location header that's sent back in the response. So, for example, if I post to users and I have a payload inside my post that the processor, the resource processor, can use to create a new record, it will save the data, perhaps save it to a database, and then create a URI and signal that to the client. Put, on the other hand, is typically used to update a resource. And so in this case, you're updating a URI. You might take the URI that was returned from the post, and you can subsequently put to it and change it as you like. But it's important to note that you can do both with either, right? You can actually create and update records from post, and you can create and update records from put. So it's, some discussion is definitely advised. One common question we get, and I'm going to go ahead and nip this one in the bud right here, is, how do I use this wide cran box of HTTP verbs from a browser, from Ajax? Because the browsers only support GET and POST traditionally. And one solution for this is the hidden HTTP method filter that ships with the core Spring framework. It's a filter that sits in place in your web application and routes calls that are sent over POST or GET to the appropriate controller in the backend. So you can still have your cake and eat it too. You can have your Ajax clients and still use the full gamut of HTTP supported verbs. The way it works is you have a request. The request has an underscore method request parameter, or rather, and then that underscore method is equal to a verb. And so if you have underscore method equals delete, you can post to the endpoint you want to actually delete and specify underscore method equals delete. Spring MVC will route that call to the delete controller on the back end. Status codes are a way of conveying metadata about the request, with the response. Status codes are broadly divided into 5 different categories. These are numbers, and they have well-known constants. And actually, Spring MVC provides the HTTP status enum if you're looking for kind of a good enumeration of those. But the 100 series is informational. 200, of course, is probably what you all know about. What you want, at least that's success codes. So, for example, if you make a request in a browser to an HTTP resource, you're going to be given a 200 code. You won't see it in the browser, but it is actually happening. In REST, it's very typical to use a 200 or a 201 or even a 202. 300s are redirection codes. 400, a lot of people will be aware of this because of 404, the page not found status code. And then, of course, 500 indicates that something happened on the server, something bad on the server, and thus the client needs to be aware of that. Okay, so let's take a very quick look at a very basic sort of level 2 RESTful service. I have a project here that I've checked out, and I've started the first version of it. You can follow along at home if you like. We're looking at this code on my GitHub repository. It's called github.com. It's at github.com. Oops, wrong one. github.com, the Spring REST stack. So it's github.com/Josh Long/the Spring REST stack. Has everything we're looking at here right now, and you can use it. So the application is a web application, a Spring MVC application. In Servlet 3, they introduced the ability to configure Servlet applications entirely in Java code using an application initializer. And of course, Spring supports Java configuration. So in this case, you don't need a web.xml and you don't need any Spring XML configuration. You can just use Java the whole way through. There's a very, very convenient class called the abstract annotation config dispatcher servlet initializer, which is sort of a twofer. It bootstraps an application initializer. It sets up an application initializer for Servlet 3 environments, and then sets up a dispatcher servlet on your behalf using the classes that you get from these callback methods. So if you imagine your typical Spring MVC setup, you're going to have a context loader listener containing global configuration. That global configuration, the beans that should be available to all the servlets that are under, all the dispatcher servlets that are in your web application, you specify here. And then if you want to specify the specifics to for a local, dispatcher servlet, you specify that in the servlet config classes. We also install a few filters. We need a hidden HTTP method filter, as we described, and a multi-part filter. We also want to support file uploads, and so we're using Servlet 3's file upload mechanism, right, the Servlet part API. So here I'm actually tailoring, the Servlet registration object that we get back after this class has registered our dispatcher servlet for us. We're given a chance to tailor the registration a little bit, to customize it. And all I want to do is make sure that the servlet container knows where to store any files that we upload. So here I'm creating a multi-part config element, specifying a path, specifying the max size of the files, and so on. Nothing particularly fancy. And then finally, we get to my Spring MVC configuration. To support file uploads, I've installed a multi-part resolver that uses the standard Servlet 3 based multi-part file support. I could have just as simply used the Commons file upload based implementation, and that works in environments prior to Servlet 3.0. It's a configuration class, so for those of you who haven't seen this before, this corresponds roughly to a XML file, and beans are described by @bean methods. Each @bean method is instantiated, it's invoked by the container at startup, and the return value is stored in the context and made available for injection and so on, and it is given all the lifecycle services that you expect for beans in the Spring container. We have component scanning, so this is telling Spring to look in this package and below it and find all the beans annotated with @controller or @component or @service, etc. And then finally, we have @enable and web MVC. This corresponds more or less to MVC :annotation driven in the XML world. This does a lot of things for you on your behalf based on convention. So for example, if you have a JSR 303 in a JSR 303 implementation like Hibernate Validator on the class path, it'll automatically support validation using that API for forms and for HTTP endpoint calls. If you have Commons file upload or Servlet 3 API on the class path, it'll set up the multi-part, it'll install basic support for the multi-part stuff as well for file uploads. If you have JAXB or JAXON, JAXB being an XML to object marshalling library, or JAXON, which is a JSON to object marshalling library on the class path, it'll support that as well. And out of the box, you get support for REST, you get support for a lot of stuff. So this is a basic configuration class. We won't look too much into the other configuration classes that are basically just slightly more, we're not going to look at the application initializer classes. We will look at some of the configuration though. All right, so what we have here is a basic controller. This is what you would expect. This is a it's a reasonable controller. It's absolutely fine. It's definitely RESTful. It's level 2 compliant. It's a controller that's meant to, manage user entities. These are entities that are coming from JPA, but that's incidental. This is just the domain that I'm trying to model here. I have users, and then users are able to manage customers. So it's a one-to-end relationship, and we want to be able to describe that relationship in our RESTful services. The users themselves are, it's like a CRM, if you will. Users log in, they can manage customer data. So you can see there's a few different, oops, I deleted this in the last webinar. Sorry about that. You can see there's a few different methods here. There's a few different methods that you can use that correspond to the kind of things you would expect to do in web applications. We have a endpoint here that is equal to users / and then it expects an ID and then / and that's it. So that's so it's users and then / ID, right? Like so. That's an example URL. Okay. We want people that make a delete HTTP call to that URL to be able to delete the resource. So all that does is it takes the user parameter, which is this guy here, takes a user parameter, extracts it, and then makes it available as a long. It converts whatever value is specified in the URL and makes it available as a long in the argument list for this method. And then you're given that, and all I'm doing here is I'm delegating to a service which goes ahead, it actually deletes the resource from the back end. If I wanted to load the same user, if I wanted to read the data, I could do an HTTP GET call. And again, I'm going to pass in the user ID, and I'll return the user data directly. If I want to load all the customers under a user, I can use this endpoint. This is a users / 21 / customers, or users / and then the path variable. And all I'm doing here is I'm creating an array list, and it's basically an array list of type customer. I've created a subclass simply so that I can bake in the generic information to make it easier on marshalling. And I return all of the customers for this particular entity and return it back to the client. So what they're getting is a collection of customers that belong to this user. Let's see, what else do we have? We have an endpoint here for loading a specific user. So this is actually users / 21 / customers, and then / customer ID, right? So user ID and customer ID are required. We specify that in the argument list here. In our case, we happen to ignore the user ID, but we could theoretically use that to check the relationship and to check that the request is valid. And so that's pretty simple. I mean, this is all just sort of basic. We're managing data. We're managing the mutation of state in our application, delegating to a service where appropriate. We have a user profile photo controller. And the user profile photo controller is, it's a controller that manages the file, the photo that's associated with the user profile. So you can upload a user profile by calling HTTP post against the URL users/21/photo. The HTTP post method has a couple of arguments. We expect a user ID, of course, and we expect also the multi-part file argument, which we specify as the second one here. This is taking advantage of that multi-part support that we installed in the configuration class. And then we simply use that multi-part file object to extract the bytes from the input stream and then pass that to our service, and we store that somewhere. It doesn't matter, but we're storing that data in our backend system per presumably GoodFS or something, MongoDB GoodFS is a fine choice, or a file system or SAN or whatever. We also specify a media type because we want to know how to serve it back up later on. And then we signal that we've done all this by creating a headers object, creating a URI to represent where the photo has been updated. In this case, the URI is the same. I made this a post instead of a put because I want to be able to show you how this works from a browser and to show you, how easy this works. This is the same API you'd use from a HTML file upload form as you would from REST, right? I'm creating a headers object here. The headers object has the URI of the photo. I set it as a location header, and I return what's called a response entity, which is a subclass of the HTTP entity type. Response entity can accept headers, a payload if you want, and also a status code. So HTTP status accepted signals to the client that the request has been accepted and that it's going to be processed. Okay, so this is 201, I think. 202 rather. I'm sorry. This signals that the processing could take a while, and you should check it out. Another option might have been to do create it HTTP 201, like so. I have another endpoint here where I'm going to say, okay, when somebody makes a request against that URL, I want to read the user data. So all this does is it reads the user profile photo and wraps it in a DTO kind of type that we have here called the profile photo. All that does is it wraps the bytes and it stores a media type for representation back to the client. We create a HTTP header object, set the content type from the profile media type that we stored there, and then we send back the bytes, right? So this is actually just bytes. The get photo returns bytes. We set the headers and we set the HTTP status okay, and then we stream that back to the client by returning our response entity. Okay, so let's actually take a look at all this in action. If you go to localhost users 21. Oh, sorry, hit the context path, REST. So there's our first request. You can see I've actually made a request against our endpoint, and data is coming back from the database, as you might expect. I have a profile photo, right? This is a photo of my Spring Source dog here, comfortably sleeping on the Spring Source beanbag. I have a customers collection here. We can actually see all the sort of, no, that's not Norwegian, go away. It can return all the customer data associated with that customer, with that user, I mean. So yeah, I mean, you can see this works. I can delete, I can make changes to it. But there are some flies in the ointment, if you will. First of all, those URLs are all very hard-coded. They're all sort of, fixed. If you know where they are, that's great. If you don't know, then hopefully somebody like me who implemented the API has written good documentation. But if not, then you're sort of just left to kind of wonder and puzzle at where it could be and what's expected. Also, the URLs themselves, even if you do know them, they could change. And if that happens, then your client code will break. So, it's kind of fragile in that respect. You want to build something that is long-term friendly, right? So there's something called, it's the model that is unpronounceable. It's HATEOAS or HATEOAS or Hypermedia is the application of engines, is the engine of application state. But basically, we'll just call it Hypermedia. Okay, Hypermedia is a way of giving enough information to the client so that he can navigate the service topology without any a priori knowledge, right? So this is mostly helpful for the developer. Nobody's imagining that you're going to build some sort of autonomous artificial intelligent client that can just, navigate without having to ever look at it before. That doesn't happen. But it is very useful. It makes it very easy to interact with it and try out the service. This takes a little bit more work, but it's definitely, it'll help you build an API that is long-term friendly, right? So much of HTTP and much of Hypermedia is geared towards writing software that is resilient in the long term, right? At the cost of short-term efficiencies. And that's a good thing, right? You want software that scales in the large. So Hypermedia is a way to do that. In practice, what does that mean? It means that instead of returning a user object from our controllers, we instead return something called a resource, which is an envelope, if you will. And the resource contains the payload, in this case, maybe our user data or customer data, as well as links. And these links are basically a mapping of possible navigations and the URLs that are associated with those navigations. Links are dynamic. They can be changed or selectively included or excluded based on the state of the resource you're trying to work with. And then the API is no longer these URLs. It's the rel itself, the customers, right? There are several common standard rels that you can use if you want that are part of the standard. But you can also create your own, right? This is kind of arbitrary, and that's the beauty of this, is that you can do your own. If you have ever done HTML and CSS, you'll recognize this structure as well. A link in CSS is used to import a CSS style sheet into the browser, into the DOM. And so this is just one very specific application of what is, in general, a very, very flexible construct, okay? So we're going to use a project called Spring HATEOAS, HATEOAS, to modernize our application and bring it to level 3 compliance on the Richardson maturity model. Let's take a look at a reworked version of our application. Close all this stuff down here. Remove this. Okay, and we're going to go ahead and add the HATEOAS-based version. And voila. Wait for that to start up. Okay, so the code in the HATEOAS example looks very similar to our previous one, right? We've still got our user controller. Our user controller has been reworked to accommodate this new API, right? To accommodate this new Hypermedia-centric aware, Hypermedia-aware world. So you notice that our endpoints are now all returning HTTP entities with payloads of type resource. The resource type comes from Spring HATEOAS. It is, as I said, an envelope. It is, very, very easy to create these things. However, you tend to do it a lot. You're going to need to do it anytime you see a user or customer resource. You're going to want to create these resource objects. So there's a very good pattern to use something called a resource assembler. And a resource assembler, for example, user resource assembler looks like this, right? It's just it implements resource assembler mapping from user to type resource of user, or like that. And the method basically is this: you have a resource user, to resource taking in a user. We use a copy constructor and we null out the password so it's not sent back to the client. I don't know if you saw that my password was visible in the original one. It's kind of awkward there. And then I have the ID. I create a resource of type user and I give it the payload, which is my user entity. And then I create a collection of links. And this is really powerful here, right? I need to give the client links so that it knows where to go, right? These links are link rels, right? They have to have URL. They have to have hrefs that map to actual URLs in the application. And one grimace is when he thinks about having to, do actual string munging to create those URLs, right? So Spring HATEOAS makes it dead simple to create these URLs. You can actually use this fluid DSL from the controller link builder API, and it's part of Spring HATEOAS, to create a link to a method that exists on a controller type. So remember, we have a user controller, and the user controller has a method for loading things with Git, and the request mapping specifies a URL. This approach here inspects the request mapping information on that method, and then uses that to generate the link. And so what you do is you end up calling the method, and you're calling the method on a proxy that looks exactly like the controller itself. And if you have a path variable, as we do, then you should provide a real value for that, because that contributes to the construction of the URL itself. But everything else, for example, if you injected a servlet request or a request parameter or anything else, that can all be null, because it'll be ignored. The only things you need to care for are any arguments that will contribute to the construction of the path. And this is pretty clean. I mean, this is DRY at its best, right? Here we're reusing the request mapping information on the method itself. If Java had lambdas or delegates in a real way, then you might be able to reference the method itself directly. But this is really, really elegant. This is really clean. So the first link we're going to create is a self link. This is very convenient, very common in HATEOAS-based architectures. And it's so common that this link builder actually has a convenience method with self-rel. So it'll just create a link whose rel is equal to self. And we do the same. We do similar things for our customers rel, right? So we want users /21/customers to do something, and we call this customers. That's the contract. This is the API. This is what we have to keep stable and fixed over time. Then we have another one for the profiles, the photo, right? So I have a photo rel. This maps to users /21/photo in this case. We put all those links together and put it on the user resource, and then we return that. And we're off, right? And this is actually, we have the same pattern applied for all the customer data as well. We have customer resource assemblers that loads all the customers and creates resources out of them. All in all, I think this is very powerful. Let's see. Is there anything else we need to look at here? No. The profile photo controller hasn't changed. There's no reason for it to change, really. The only thing that we have changed a little bit is we actually have, when we create the URL, we actually use the Spring HATEOAS constructs to get that link. Because now that we have a class where we've codified the recipe for creating the links for various entities like the user and the photo, why bother inlining it here? We can just reuse the one we've already got. So when you upload the photo, what we do is we create the headers. We create a link header to be sent back to the client, and the link header simply toStrings the collection of links that we specify here. So that way the client knows where that resource lives now. Okay. We have another endpoint here for loading the photo. We've seen this before. Nothing has changed really. So if we look at this in practice, now we've got this thing loaded. We can actually interrogate the same information, same data, same endpoints from this new application, the HATEOAS Aware application. And you can see we've got quite a bit more data coming back. We have, let's take a look at something slightly more abbreviated. There we are. Here we have the payload itself, the whole JSON structure, and the first property you see is the links property, the first element, and then the links is just a collection of link elements. As we're representing this in JSON, the links are constructed as JSON and not as XML. So you see rel equals self, href equals, and then there's a URL automatically built for us using those link to methods on constructs. We have a link to the customer's information. We have a link to the photo information, etc. And then, of course, we have the actual information about the resource, the username, the first name, last name, the media type of the photo, etc. This is a lot more powerful when you see it in terms of the REST shell. So Spring provides we have a REST shell. It's called the Spring REST shell. You can use it very simply by doing brew install REST shell if you're on a Mac, or otherwise it's fairly easy to get started and get it going on other environments if you have just a source code, because it's just Java. So I'm already in the REST shell, so I'm going to go follow AOS, right? Whoa, follow, and that gets me into the actual application URL for the context, and then from there I can follow users, follow 21, and then now my URL is, I'm treating it like a directory structure. I can actually traverse it and interrogate it. I can do things like get the resource. And instead of looking at that giant condensed blob of JSON in the browser, I can actually look at a very pretty printed JSON structure that's returned back to the client here. I can see the HTTP status codes and the content type and everything else that we expect. I can even do more, right? So instead of manually trying to infer the links, and I can parse, this is fairly simple. I can parse the JSON structure in my head, and I can see these links. But there's a very convenient tool you can use called Discover. So you say Discover, and it gives you a table of the possible navigations as well as their rels, right? So here I've got a rel for self, a rel for customers, a rel for photo. And I can, for example, follow customers, etc. And then, get that as well, right? So this is very, very powerful. This is a nice way to interrogate the API. The REST shell is a easy tool to use. It's, and you can actually replay things. It's got line feed support and all that stuff. And read line support, sorry. So, moving on. So I think that's a marked improvement over the first version. It's certainly a more powerful API. It's definitely more expressive, and I think the intent is more apparent to the user. However, let's be honest, we're still doing a lot of data sort of, muling. We're taking data back and forth. We're just moving it from HTTP back to the service tier where it's going to be persisted, deleted, modified, mutated, etc. with our JPA repositories. So why not cut out the middleman? And we can, right? It's very easy. We have a project called Spring Data. Spring Data has as one of its main concepts at the root of it, this notion of a repository. A repository is like a DA. It's another fancy word for a data access object, or DAO. It's just code that is concerned with the data manipulation logic associated with persistence in some sort of backend data store. We have Spring Data JPA, which works with JPA, Spring Data MongoDB, which works with MongoDB, Spring Data Gemfire, which works with Gemfire, Spring Data, Neo4j, for example, that works with the graph database Neo4j. And we have third-party, open source bindings from the community that work with Elasticsearch and Solr and the like. So there's a lot of different options out there, but the basic concept is the same. You, instead of writing a repository, a data access object directly, you simply create an interface that extends, you create an interface, and you can optionally extend one of the Spring Data interfaces, like the paging and sorting repository. And this gives you generified, convenience methods for handling and manipulating your data access, for that particular entity. In this case, I've got a user repository that is meant to work with the user objects who have primary keys of type long. And there's a lot of methods that are in that paging and sorting repository that you get for free. Things like find one, so you can search for a single one. Find many. You have a lot there. You have paging support as well. You have the ability to do sorting and just a lot of functionality already out of the box. Even if this is just an empty implementation, empty interface, you'd already be ahead of the game. But it gets better. You can actually, based on convention, create methods, in the interface, like this one here, for example, user find by username. And based on the name of the method itself, which is a convention, Spring Data will create the query for you. And the reason it does that for you is because it can, right? If you look at the query, if you look at this method, you see that this method is going to load a JPA entity called user, and it's going to predicate it on the username parameter. Well, close your eyes just for a second and, imagine what the implementation logic for that code looks like. It's not hard to imagine. It's just, it'll ultimately look something like this, right? You're going to ultimately get a query passed into an entity manager somewhere that says select you from user where username equals whatever. In this case, the parameter that's passed into the method. And if you and I can imagine what that query looks like without having to write it, then why bother writing it? It's clearly something that can be automated, and that's the whole point, right? This repository is just an implementation. You give Spring Data just enough information for it to do all the drudgery and boring data marshalling work for you, okay? A more complex example, for example, is list user, find users by first name or last name or username. And here I'm saying that, I want to predicate my results based on all three of these parameters. This ultimately looks kind of like this. It looks select you from user where username equals whatever and first name equals whatever and last name equals whatever. This is very easy to see. It's very easy to understand. It doesn't take a lot of code, and you get it for free. The Spring Data knows what to do in a lot of different combinations. You can do ORs and ANDs and so on. And if you really want to override the query, you can actually use an @query annotation on the method itself and specify the query that should be used. So you're not even conceding that much control, and you can override some methods, for example. So Spring Data can do 80% of the implementation interface, and then you can do the other 20% if you like. Of note for us, however, is that there's a project called Spring Data REST, which builds on top of Spring Data and makes it dead simple to transparently export these repositories as RESTful endpoints. So here I've got the @rest resource annotation, and I specified that I want this available at the path users, and I want it to be mentioned as a user's rel in all places where we have that. Spring Data REST is it's sort of like an application already. It's prepackaged. You just put it you include it in your web application, and Spring Data REST will take care of automatically standing up any repositories that you have this annotation on. So let's see how we've managed to rework our code to simplify it, to get rid of a lot of that sort of tedious back and forth with data, because we can let Spring Data REST do it for us while still keeping control if we want. So I'm going to remove this guy, and I'll go ahead and add the HATEOAS data project. And we'll go ahead and debug that guy. Okay. The code again is fairly similar to about the same as what we had before. Actually, it's a little bit less. You'll note that we've gotten rid of the user controller class. It's no longer there. We have the profile photo controller, of course, because Spring Data REST has no idea what to do with file uploads and the like, right? And that's acceptable, right? All we've had to do, though, to maintain our API was to create these two methods for this one little edge case. The rest of it's all fairly taken care of for us. There are a couple things we want to, we have every right to want to override or to intervene in the process, and we can. So the first thing we're going to look at is a customer event handler. This is annotated with @repository event handler, and it's connected to the type customer, which is a JPA entity. And the idea here is whenever Spring Data REST attempts to persist or delete or whatever, your JPA entity, you can get a callback by annotating a method with the appropriate handler annotation. In this case, I want to be notified before Spring Data attempts to persist this DTO, this entity rather, into the database. And I can interrogate the state of it. I can say, okay, well, if it's got a first name and a last name, great. If it's got a valid user, that's important too. And if it has all those things, then go ahead and set up the automatically generated sign-up date, and then let Spring Data persist it, and it'll get saved to the database for us. I can also, I can do things like auditing logs, for example, after deletions or saves or whatever. So you have a lot of different callbacks. I've only shown 3 here, but the point is there's no reason you can't, you can't have your cake and eat it too. You can let Spring Data REST do most of the work, but if you want to override certain bits, absolutely feel free. One consequence of this change, however, is that we no longer have a user controller class to bind to, right? You'll recall that when we created those links before, we used the link to Fluid API and then the method on, and we specified a controller class. That controller class doesn't exist anymore. We're letting Spring Data REST do all the hard work for us. And so we have nothing strongly typed that we can use. However, our RESTful API follows a convention, and there is a link builder that Spring Data REST provides that is aware of that convention. And so we can create our links still with some ease, Instead of using resource processors, however, it's pretty convenient just to create a little class that has all the recipes for creating links. So you might, a good convention is the entity and then the links. And here I've got methods that'll generate a self link, right? I'm using the entity link for single resource, and it'll link to the RESTful controller that handles user data, and it'll create a resource of /ID. So it's users /ID. And I'm going to call that my self rel. I can link to users /ID customer, right? So I'm actually using the /DSL method to /customers. and I'm creating that link, and the rel will be customer rel just as before. And I do the same thing again for the photo. So user ID / photo with link rel photo, right? This is very convenient, very standard stuff, and you can use this wherever you need to have links set up for you on your behalf. Let's see. The only place I need links in particular is in my profile, my photo controller, for example. Here, I'm creating my my photos and I'm returning the links themselves. I'm using this new user links instead of the old ones, instead of the links that I was creating before the old way. Other than that, this is all pretty much the same as we saw before, except we don't have to write all that code associated with managing the data. So let's go take a look at what this gives us in the application. So I'm going to change the context because we've changed the application after all. But you can see the first things first. I get a much more friendly, pretty printed response from the service. It's certainly nice. It's easy to navigate. The information, of course, is there. And I've gotten some links that I didn't create manually that are just there for me as a convenience, that are provided by Spring Data REST. So, for example, I can get access to the collection of customer data from unrelated customers by following this one. If I go to users, I can actually get all of it. And if I go to the root, I get a root collection URL. So for both the customers and the users. So I've got a lot of power here, for very little work. I can also support something called, I can support paging, right? I would argue that this is probably not something you want to share with your clients, but if you are building a filtering screen, a search screen or something like that, and you want to have an easy way to do that, then take advantage of this facility. It's already there. It's very convenient. It gives you a page element that has the sort attribute that tells you in which order the data is being sorted, and it tells you the offset and then the limit in the application, and you get the resources back. So I can actually page through, and I can say, okay, I want page 2, limit 2, as I've only got 4 records, and you can see it's being given back according to the first name and so on. Okay, so that's very powerful. I think we've achieved a lot, but one common question we still get is, what about security, right? So we've certainly simplified the task of writing a REST API, but we haven't really addressed something that we're often asked about, which is security. Well, first things first, if you're using REST, it is just HTTP. You can take advantage of HTTP's native primitives, including HTTP authentication, HTTP basic, and digest. I would recommend you stick to TLS at a minimum, SSL basically, for this kind of stuff. HTTP basic, especially if you're doing HTTP basic, in which case the password is in the clear and there's no encoding. If you can do HTTP digest, that's better. This only works in situations where you can trust the client, the client that's connecting to your RESTful service, to keep a secret. This is not going to be true, for example, with a web page. You can't go to a JavaScript AJAX client and store a password and then expect that password to be a secret, right? That's by definition, anything you can view source on isn't a secret. And so, this does work, however, if you have for example, a desktop binary application and you've encrypted the password and the application itself is untampered, it's tamper-proof, for example, or you've delivered an iPhone or iPad application through a marketplace and there's no chance really for the users to tamper with the application, then that is probably an okay way to go, right? That's simple enough, and Spring Security has made this simple for ages, right? So there's no reason to reinvent the wheel. This works fine. But as often as not, this isn't going to work for some people, right? There are a lot of reasons why you need something more robust. One, of course, is the case of the browser, where you want to be able to securely work with credentials with a service, but you can't afford to have the user transmit that stuff in the code, and you can't afford to hard code a password in the JavaScript code. Another example is where you want to decouple the service access from the client, right? So if you have a user context, as you might, for example, when using Facebook, Facebook has the ability to create, it has a RESTful API. Facebook's RESTful API is open to anybody, right? Anybody can create an application that will act on behalf of a Facebook user and interact with that API. The way that you see that all the time when you install things on Facebook, like Farmville or whatever, or when you set up iPad or iPhone applications that aren't from Facebook.com, some third-party service. There's lots of different Twitter clients as well. Well, all these clients, you can't trust all these different clients with your password. You don't know if they're all, if they're all scrupulous or not. You don't know if you can trust them, and frankly, you shouldn't have to worry about that. You just want to be able to install the latest and greatest Twitter client, and if it happens to improve upon the client that's given to you from Twitter, then that's great. But you don't want them to have your password, because what if you were wrong? What if it's not a great client? What if you can't trust them? You don't want them to have access to your Twitter credentials or your Facebook credentials. So what you do is you decouple it. You use something called OAuth. You see the OAuth dance all the time, right? So here's, for example, my Facebook apps or plugins or whatever, and I want to add a new one. When I go to the website and I add that Facebook, when I authenticate with Facebook, or I use the Facebook API from some other place, for example, if I want to authenticate with Facebook on some sort of third-party website, what will happen is I get redirected to facebook.com, and facebook.com prompts me to log in if I'm not logged in. And then once I'm logged in, it prompts me to approve access for the client to access my information on my behalf. In this case, I have a Spring CRM application that wants to access my Facebook API on my behalf, and I hit OK. So that's the OAuth dance, right? So the user is you as the Facebook user, and the app is some sort of third-party application, and Facebook will give that third-party application what is called an access token, which it can use to then subsequently make calls against your RESTful API on your behalf. And in this way, the client does not have access to your password, so that even if the client does something unscrupulous and you don't approve of it, they can't lock you out of your account. They don't have the password. They can't break your account. They can't do anything serious. You can always log into Facebook.com and simply disable the client. This is empowering, and it also means that you don't have this one giant global shared password. So if you change the password to Facebook.com, it would be painful if your Facebook apps on your iPad and on your TV and your phone and all these other places where you can use Facebook all suddenly broke. You have to re-authenticate all over the web. Every place you've ever used your Facebook credentials to log in is now broken. So this decouples that from the password. You don't want that, right? You want the access token approach. You want the OAuth approach. And thankfully, there's something called Spring Security Auth that makes this very simple. Let's go visit a different. So we have an API. We have a version of this application we're retrofitted to use Spring Security OAuth. Spring Security OAuth secures your RESTful API and requires that any client that accesses it has to be given permission by the user on whose behalf this client is attempting to connect. Okay. So in this example, I have a user context. I have my own notion of a user. You saw the domain model before. It's users that have customers. So I need to adapt that domain model to the Spring Security world, and we'll look at that in a second. Let me go ahead and start this guy off first. Okay, so that's starting up. Let's take a look at the OAuth implementation code. We go to the resources directory here. I've got a Spring Security configuration file. I should note that there is actually a very, very, very nice looking Java configuration centric version of this available both for Spring Security and for Spring Security OAuth. It's not quite stable yet, and I wanted you guys to be able to consume this and trust that things are going to be relatively stable as you use it. So I will update this code, and then we'll have managed to excise the last of the XML in the entire application. The only other XML we have in this entire application is our Maven build descriptor. So this is a Spring Security configuration class. I mentioned that we have to adapt our notion of identity, our notion of a user identity, to the domain that Spring Security exposes. You do that by providing a user detailed service implementation. There are lots of different implementations out of the box. There's one that connects to a JDBC backend based on queries. There's another one that can talk to Active Directory or LDAP. We have different projects that support PAM and CAS and SiteMinder, and just lots of if you look in the community, you'll find lots of different implementations as well. In our case, we just want to expose the users that we have in our database as Spring Security aware user details, right? This is the interface. So what you need to do is you implement a user detail service, and then that has one responsibility. It's this load user by username method, which serves to look up a user details object in response to this query, right? And so all we're doing is we're delegating to our service in the backend. We load up the user, and then we wrap that user with a CM user details type, which is our implementation of the Spring Security user details object. So here we're doing, nothing particularly fancy, nothing special. We're just adapting our user to a user details type by creating authorities. In this case, I've just hard-coded role user and two scopes, read and write. The strings the strings for the scope are arbitrary. You can provide your own. Again, if you're going to use Facebook's API, for example, they'll have scopes concerning your photo, your timeline, your wall, etc. In this case, I've just got two to keep it very simple. But you can be as nuanced as you like here. You can say that this user has access to just one section on the website and one kind of resource, whatever. You can give them one-to-end roles. You might have an admin, a regular user, a view-only role, etc. And each one of those has a corresponding set of scopes that they can assume. Other than that, there are housekeeping methods here to tell Spring Security if the account has been expired, to tell it if the account is enabled, etc. Right? Nothing particularly special. Let's see. Okay. So once we have that, we have to do one more thing. We have to outfit our application to support the OAuth dance, right? Part of that is we have to establish a few OAuth endpoints, right? So that the client has a place to actually connect. So here I've got a controller that handles the confirm access and the OAuth error endpoints. These endpoints are used by the navigation from the client side. So when you do the OAuth dance, these endpoints get called. You can just copy and paste this implementation. It literally is quite simple as it looks. It's almost directly usable without any change. You just change the package, I think. Other than that, we've installed a few old school, .html files, actual HTML views. These aren't RESTful, but we need these to present to the user, to prompt the user for approval and username and password and so on. But other than that, this is basically the same thing as the Spring Data REST version of the API. We've got, let's see. Oh, I've done one more thing because we have Spring Security. I've stood up a user endpoint, just /user, and that gives me the chance to ask my API for the currently logged in user, right? The currently authenticated user, the principal. So it's just /user, and all I'm doing is accessing the authentication object that I've had Spring MVC inject for me. This is a Spring Security construct, and Spring MVC knows how to inject it if it's available. And I use that to access the CRM user details service /.CRM user details instance. And then from there, I extract the ID, and I'm able to build a HTTP entity with a resource type that has a type of user. Okay, so this is the current user. And of course, I can do everything I need to do just like I would before. So let's take a look at this. Let's actually log into our application. First things first, you'll note that we are not able to access the application. We're locked out. We need to actually sign in first, right? So I'm going to go to /CRM HTML. This is a regular Spring Security form. There's absolutely nothing special about this. If you've studied or looked at Spring Security at all in the last, many years, it looks like this. You have an endpoint relative to the context root called j_spring_security_check that expects two passwords, two well-known request parameters. One is called the j-username, and one is called j-password. And here I've got j-username mapped to a text field and j-password mapped to a text field for a password. And that's it. I mean, this is it. That controller, this security feature, is provided by Spring Security. Okay. So I'm going to go ahead and sign in. I'm going to sign in as my user, right, the user in the database. And when I do, I'm redirected to the root resource, and now I can access it. Now everything is there. I can actually work with my data just like I did before. I can go to users 21, etc. I can go to the customer's endpoint, etc. But that stuff wasn't there before. That's only because I signed in. Once I'm signed in, now I can do anything I want, right? So the next question is, of course, how do I consume this as a client? How do I do the OAuth dance as a client? And that brings us to the next bit. We need a good story for consuming OAuth services as a client. Spring Social is that story. It provides a base authentication and authorization client for OAuth, both 1.0, or all three of 1.0, 1.0a, and 2.0. And that platform handles all the drudgery of consuming OAuth services. It's used quite a bit. And then on top of that, there are typically bindings, API bindings that you can use that are strongly typed and that kind of mirror the domain model on the server for the client for Java users. If you're using JavaScript and you want to consume OAuth, there are libraries like Kujo.js is a rest.js that'll help you with it, or if you want to use JSO.js, that's also an alternative. But for Java clients, Spring Social is absolutely the way I would go. Spring Social provides these type-safe bindings for lots of different APIs as well. So if you actually want to integrate with somebody else's REST API like GitHub or TripIt or LinkedIn or Twitter or Facebook, we have inbuilt projects that support that at SpringSource. And there are lots of other bindings that the community itself has developed. For example, bindings for Salesforce and for Flickr and Bitbucket and Tumblr and just anything else you can imagine, right? And these are all well enumerated on the github.com/springsource/Spring Social wiki. Okay. We want, however, in this case, to create our own client. We want our own binding for our own API so that we have a client that we can consume our OAuth services with in a secure way. So let's take a look at our OAuth client here. I've got a little project called client. Remember, you can use Spring Social inside of another web application. So you can imagine a web-to-web communication scenario. I could have an authenticate with CRM kind of button somewhere maybe, or I could have an Android app or whatever. I could have a web-to-web kind of communication, or I could have another client, existing on a device like an iPad or an iPhone or an Android device, or I can do it in HTML. I can do an HTML application, or you can do it in public static void main. But there are some caveats to that, right? Because you still need to prompt the user with a web page somewhere. So I've written a little client I've written a Spring Social binding and a client here. My binding, I have mirror types for the server-side types. This is not the same type as I have on the server. I have a customer, a profile photo, and a user. I can distribute this API, and the client will never know, about the types and the implementation on the server side. To teach and to adapt Spring Social to your API, you need to provide a few implementations. First and foremost, you need to provide an API adapter. In this case, I want to provide an API adapter for my local API. It's called CRM operations. It's an interface in the same style as a JDBC JDBC operations or Twitter operations or Facebook operations interfaces that you get. And this provides convenient one-line access methods that you can use. The concrete implementation is something called CRM template, and we'll take a look at that in a minute. This API adapter tells Spring Social about certain things. It can answer questions about your API, like, hey, is my API still alive? Is everything all right? Is it working? If so, then the test will return true. In this case, my implementation of that is just a test that an attempt to access the current user doesn't return null. I can tailor the connection information, right? I can tailor certain information Spring Social needs that is common to all APIs. So, for example, I can override the user ID by just giving it the ID. That's my provider user ID that maps back to this particular user. I can set the display name for the user. In my case, it'll be Josh Long, the username I logged in with. I can also build up a user profile here using a Fluid DSL user profile builder, setting up the pieces I need. And also there's an update status method. This update status method is optional, but it's very common in service providers like Twitter or Facebook to have an implementation of this. So, for example, on Twitter, this would basically correspond to a tweet. On Facebook, this would correspond to updating a wall, etc. In my situation, in this CRM application, there's no real notion of updating your status, so I've just logged that it's not available. It's basically a no op, okay? So there's nothing there. I need a service provider. This extends abstract to OAuth 2 service provider, and the service provider is responsible for constructing the OAuth template that we need, the OAuth 2 template that we need to make secure OAuth aware requests to our service. and I need to provide the base URL. And I do. It does. It's just basically housekeeping. It's not. There's nothing really particularly interesting about this, but you do need to do it because you need to provide. You need to provide the connective tissue between Spring Social's machinery and your API. That intersection is right here. It's at the get API method that's provided by this service provider implementation. The method is given an access token, which is obtained after Spring Social has performed the OAuth dance on your behalf. And you can use that access token to create a CRM template or a concrete implementation of the API type. In this case, I need the access token and the base URL, so I pass that into my constructor. And then we can actually look at the CRM template. The CRM template extends the abstract OAuth to API binding class and implements CRM operations. I do a few things here in the constructor to store the access token and to customize the REST template. But other than that, this is just a client. It's just using Spring's REST template object, the REST template that has been in Spring since 3.0. That makes it dead simple to make one-liner invocations against an HTTP resource. I have client-side mirrors to API calls that you can do on the server RESTfully. So here's a client-side typed method that you can use to create a customer. I create customer data. I create a HTTP headers object. I set the content type, and I create a map. Basically, I'm just treating the customer. I don't even need the full POJO. I can just use a map, string first name, last name, etc., and then provide values. I create an HTTP entity, and the HTTP entity has the data as well as some headers specifying the content type. And I use the OAuth access token aware REST template that I get from the base class, and I post to my customer's endpoint on my RESTful service, and I expect a response entity back. Okay. The one thing, if you recall, in the implementation of our service that we did for this particular endpoint is we returned a URI signaling to the client where the newly created customer record lives. Okay. So here's the URI, and then I use that to actually load the customer data, the fully configured instantiated record. This customer record just does this. It just calls, it calls the REST template, and it says, make an HTTP GET request against users /ID /customer /customers/customer, and give me an object of type resource customer. I unwrap that. I have a little convenience method here since I do a lot of unwrapping with customer and user objects in this class. And that simply gives me back a customer detail that I can hand back to the client. And we do this a lot. I mean, you can see, remember, you'll recall earlier that we uploaded photo data. Here's that same method, set user profile photo, pass in bytes and a media type. We create a byte array resource, which is a Spring. I'm creating an anonymous subclass of a Spring type resource, specifying a file name to help with the MIME type handling. And I get the absolute path. And then I put that in my multi-value map and use that in the REST template. I say post for location. And I post to users /current user .get database ID /photo. And I pass in the multi-value map, which contains my file data. So this is the programmatic REST template version of that file upload form that we looked at earlier. All of this, all this comes together quite nicely, and then we use it in our example here, right? So here's an example of a public static void main class where we set up a Spring application context and then get access to the client example bean that I've created. That's this class itself, the one we're looking at right now. And once the bean is created by Spring, the after properties method gets called, and we do work to set up the connection, right? We specify the connection URL. We specify that we want the OAuth 2 operations object. We specify which scopes we want and the type of OAuth connection we want. And then I use the runtime object to literally just open up Google Chrome on my local machine and load up the authorization URL. I approve the request, and then I'll pass that back to the process through a swing input dialog, and then use that access token to create my CRM operations connection. So let's take a look at that in a minute. But once I have the connection, I can then do things you'd expect to do. I can fetch my user profile from the connection itself, or I can ask the connection for a concrete type, CRM operations, an instance back from Spring Social of my CRM template implementation. And then once I have the API, I can do whatever I want to do. I can call, I can ask it for the current user. I can create new customer records. I can get the current profile photo. And in this case, for example, I want to get the current profile photo and persist it to my local desktop, the desktop on my Mac. So let's go ahead and run this, and we'll go ahead and manually oblige this dance. It's worth noting that like I said, you can do this from a web browser or web application as well as from another context like an Android application. And you can do that very readily with something like Spring Android, which supports Spring Social. Okay, so here we go. Run this guy. It pops up my very basic HTML rudimentary sort of authorization form on my web application. It says, "You approve Android CRM with the following permissions?" Yes, I do. And it redirects to a URL of my specification. We don't care what the URL is. The URL is irrelevant. All we care about is that it's conveyed a access token in that response. If you're inside of an Android or an iPad device, you might use a web view, and you can trap the redirected URL and then get the access token in from there. In this case, I'm just going to manually pluck it from the URI and then paste it into this dialog that has since popped up because I prompted it in there in the code. I'll feed the access token to the code, and then it will start doing things with the RESTful API. So you can see here that I've got, I've made a request against the user to get the current user, to authenticate and then get the current user. And then I'm going to get the photo data here. So here's actually a call to OAuth users 21 photo. You can see it's getting setting the accept headers and making a GET request. That's okay. I was given back a byte array, right? So I'm invoking the byte array HTTP message converter. The profile photo mine type is image JPEG. And then we'll see that that photo actually gets saved to the desktop as well. So here's the photo that we uploaded earlier, right? The one in my profile. Right, so it's the same thing as we saw earlier. And that's it. I mean, that's a very, very powerful use case. We're actually now securely talking to our RESTful service. We could as well also enable SSL and TLS. That's a very good idea. So that's it. I think that's we've kind of looked at how to do a basic RESTful service. We've looked at how to make it more sophisticated by supporting Hypermedia. We've looked at how to remove some of the boilerplate code typically associated with this kind of stuff by using Spring Data REST and Spring HATEOAS. Then we secured it using Spring Security and Spring Security OAuth. We've used a tool called the Spring REST Shell, which is very convenient for interacting with Hypermedia-aware RESTful services. And then we've used Spring Social to create a client that you can use in Spring Android and also by itself in a web application to communicate with that secure OAuth service. There are lots of great resources you might check out, including Roy Fielding's original dissertation on REST. Check out the code, of course, at github.com for Spring Source and for the REST shell. Oliver Gierke gives an amazing talk on Hypermedia. There's a video from Aura Dev from last year. It's a conference. I definitely recommend you check that out. Les Hazelwood has done a great talk on designing a beautiful JSON REST API. Ben Hale, my colleague Ben Hale, also does a great job. He's got a talk that's from Spring 1 2GX last year that you can get it at URL as well. And as for me, I'm on Twitter at Starbucksman, STARBUXMAN. The code for this, everything we've seen here is at github.com/the Spring Stack. Actually, it's not RESTful API design, but it's called the Spring REST Stack. And the links, the presentation itself is on SlideShare at slideshare.net/Josh Long, REST APIs of Spring. All right, I think now we'll move over to take some questions.
Actually, Josh, I'm going to do a quick plug if you back up one slide.
Yes, sir.
Ben Hale also has 2 sessions accepted that are continuations of that Spring 1 2012 talk that Josh has up on the screen right now. If you are in the Bay Area or interested to come to Spring 1, Ben is also going to be doing 2 follow-on talks to that at Spring 1 2013 this year in Santa Clara. So go to spring1-2gx.com and check it out. You'll see him in the web and JavaScript track for Spring 1.
I'm doing a talk. I'm doing another talk as well at Spring 1 that is sort of the client-side perspective of this talk. Like we've looked at server-side here, and the next natural question is, what about Android? What about iPhone? What about HTML5? So if you want to see how that all plays out, come to Spring 1 as well. my talk.
Jonathan Smith, who I think is our friend who's been making videos lately, was asking, this is great. If someone needs help, where should they post? And I think forum.springsource.org is a great place to post that some of the engineers monitor. If you're looking for community responses, you can also try Stack Overflow, of course.
Or reach out to me.
Or reach out to Josh. Yeah, totally.
There are my email and my Twitter coordinates. I'm very happy to help. It's my charge, and I'm very happy to do it.
So everyone, we will be posting the YouTube replay within 1 or 2 weeks. Usually, I try to get it done in 2 or 3 days if I can. But we say 2 weeks just to give ourselves a little wiggle room. And we'll be posting that at youtube.com/SpringSourceDev and youtube.com/SpringSourceDev. So Craig and Oliver have been awesome going through a freaking huge question stack. We still have almost 370 people on the line. So yeah. We had a high watermark of almost 500 earlier, which is great.
Great.
Let's see. There was 1 or 2 unanswered ones earlier. One second.
I wanted to say thank you that's Craig Walls and Oliver Gierke. These are 2 of the many ninjas at SpringSource, the leaders of these projects. Craig is, of course, the leader of the Spring Social project, and Oliver, the lead of many parts of Spring Data as well as Spring HATEOAS. Thank you guys so much for fielding the questions. Awesome. Thank you so much.
Cool. Let's see. So, they have actually gone through the entire question stack. We don't really have anything unanswered at this point. I'm just triple checking to see if there's anything missed. But yeah, they have been just rip-tearing through this stuff. One person was asking if I don't know if we have any perspective on this, frankly, but asking about a web-based alternative to REST shell. Someone else responded about Neo4j, but I'm pretty sure REST shell is a command line utility, right?
Right. I don't know of a generic REST client, but I'm sure, jQuery and rest.js from kudo.js, and they're all very good HTTP clients.
Okay. Jonathan Smith was also asking, and I think this was during the Spring Data REST part of the talk. It was about 23 minutes ago. Yeah, looking for an example with Java config style. I'm assuming that's about Spring Data REST.
All of this, the entire thing, everything you've seen except for that one Spring Security XML file is Java config, and I will even update that pretty soon. Like I said, I could do it now. It's just I didn't want to give you guys something that might change. The Spring Security stuff is a little bit tentative at the moment. We're still working on it. The Spring Security lead, Rob Winch, is doing an amazing job. If you go to github.com/SpringSource and then look for Rob Winch, and then navigate to his personal repository, you'll see the Spring Security Java config project there. It's amazing. Do check it out. And there's also support for Spring Security OAuth.
Cool. Let's see. A couple last questions coming in. It looks like he's got that one. Is there a preference when it comes to post? Let's see, hold on. Is there a preference when, hold on, sorry, this is screen's flipping out here in me a little. Is there a preference when it comes to post? Is create and put and update? I've seen the opposite, that put is for create, as in putting a new resource, and that post is for updating one. So I think the question really is about, what's the proper use of the HTTP verbs and the semantics to map them to in your back end?
I would post to an endpoint if I was going to create something, and then signal back with the location, and I would put if I was going to update something. So I don't. There's no real specific thing. Oliver, do you want to chime in on that one? Actually. I'm pretty sure he's on mute, but he might be able to say something as well.
A couple of people were asking about the possibility of the slides, and I know that you have those up on your SlideShare. Would you mind pulling up the resources talk? Yeah, exactly. Thank you. We'll also put a link when we put out the YouTube replay. We'll also put a link to the slides. And I did forget to mention that Craig Wells, who's been on the line helping out answering questions for many of you, is also going to be talking at Spring One about Spring Social this fall. It's September 9th through 12th. So again, sorry for the shameless plug for the conference, but there's going to be some pretty righteous content there. So go to spring12gx.com and check out what's coming up. Another question. Actually, just more of a comment, I guess, from Robert Thornton. Google Chrome has an advanced REST client plugin that's very full-featured. That might have been in response to, is there a web-based equivalent for REST shell?
So I normally talk about this little poster plugin that comes with. You can get it on the Firefox Market. There's a poster plugin that's quite nice. If that helps. Oliver, did you have something to say? I think I hear you talking in the background there, buddy.
I'll answer the question in text, like in QA, so it's fine.
Okay. Well, thank you so much, sir.
Question from Praveen. Will Spring Security support HTTPS SSL encryption?
It does. I don't understand. It doesn't actually export as TLS. That's up to the container, but it certainly works with it. That's just fine. It knows what to do, and it knows how to switch back and forth and so on.
Question from Vlad. I'm not going to try to Gilinski. Can you suggest web framework which integrates with REST in Spring?
Spring MVC.
I think that's the answer. Yeah.
Because everything we've seen here is based on Spring MVC. It all sits on top of it. Spring Social, Spring HATEOAS, Spring data-rt. It's all Spring MVC at the bottom, and that comes with Core Spring. So that's what the very first introduction to REST, the very first project that we saw in this webinar, the very basic REST API, that's just Spring MVC. You don't even need any extra projects for that. It's just the Spring MVC stuff. But that's not Hypermedia aware. That's what I'm saying. You do well to layer on this extra goodness.
Wei Shi asks multiple times, any support on RDFA? I'm not exactly sure what that is, frankly. I'm hoping one of you guys know.
Oliver would know.
RDF?
Okay. RDF and then lowercase a. RDF and then lowercase a.
No support yet. Plain JSON only, and we're probably moving to HAL, which is the Hypermedia application language, and there's a JSON dialect that has defined how links are expressed in representations and stuff.
Thanks, Oliver.
Thank you.
Let's see. Yes, a similar question, I think, from Andy Hamilton. Other link formats, I think this is a HATEOAS question. Other link formats like JSON LD, linked data.
No.
Oliver?
Excuse me? What was the linked data? So right now we are only supporting the link, the format you saw, which we originally made up because none of the competing standards or de facto standards were emerging really, and there was no clear winner amongst all of them. Right now it seems to be HAL. HAL seems to be the most popular one, so we have already quite a bit of support in Spring HATEOAS for HAL representations, and you can, with a flip switch in the configuration, essentially turn on HAL-based representations for Spring Data REST and essentially for all resource objects that you return. So we're probably moving that way.
Any support for Siren and collection plus JSON or anything like that?
No, actually not. No.
Just wondering. There's a lot of different formats out there, but there's definitely Oliver has a good track on the sort of the leading, more useful ones. So that's good.
Josh, would you leave your resources slide up for a minute? A couple of people were saying about 404s on your RESTful API design.
Yeah, like I said, I saw that and I actually overrode the in the URL is not this one. It's actually the Spring REST stack. So Josh Long, the Spring REST stack. I'll change the slides accordingly, but it's up. If you go to github.com and look at the most recent repository right now for Josh Long. So Spring-REST stack.
Cool. Let's see. Question from actually, I might say his name wrong, so I'm not gonna slaughter it. Oliver, this is one for you. Spring HATEOAS is at 0.5. Is it recommended for production in this state?
So it's an 06 actually. So as of last week, but we take the freedom to change APIs a bit. Right now, there are quite a few sample applications out there that are updated alongside the changes. Parts of it will actually make it into Spring 4. We're still not sure which parts, but it's definitely something to look at, to get used to the way you build, for example, links to controllers, because that's very likely to be part of Spring MVC out of the box as a Spring 4 anyway. And we have people that use that stuff in production, but that's rather agile project that can deal with a method rename or something. So, yeah. I consider it stable in terms of, okay, there are no bogus bugs in there, but we might take the freedom to change a method or class name.
Got it. Thank you very much, Oliver. Question from William Simons. How about JTA, Hibernate, JPA? I'm not exactly sure what he's that is in reference to, but.
So is the question in terms of like REST or what?
Yeah, we don't know. I think a little more context. William, if you're still on the line, maybe we'll pass on that one. William, if you're still on the line and you want to clarify.
Can I take a swing?
Sure.
If this is like the question that we got in the last version of this webinar.
He does appear to be on the line, by the way.
Oh, good. Okay. I'll speak to it just in case, and if I'm wrong, I'll clarify. If you're asking about whether you can do REST support for XA, there's no like WS transactions or anything like that for REST. So, and you probably don't want to do that anyway. It's not a very good. It's a good way to scale very, very poorly. If you want to do JTA with Spring, of course, it's well supported. We have a JTA transaction manager that sits alongside other options like a Hibernate and JTA and JMS transaction manager. If you want XA and you want JTA, you can use JTA inside of a full-blown sort of heavyweight application server, or you can use it independent, including in just something like a public static void main by using a third-party transaction manager like Atomicos or Bitronics. There's a blog that I put together a couple of years ago here on how to set that all up, complete with sample code and everything. If you're asking about how to update two different resources using REST, then you can do that by just having one call to the RESTful endpoint. Create an endpoint that actually takes more like a command message, and then you pass that down to the service tier where you have one transaction. That's where you keep the transaction management, including anything that deals with JTA. But again, if you can avoid JTA, please do. It's definitely the biggest anti-pattern of the last 10 years, in my opinion. It's so slow. Okay,
we're getting towards the end of the question stack. Hang on one second. I'm going back a little bit. Bear with me for 1 sec, Josh, okay?
Yes, sir.
Where did it go? Wait. Oh, somebody answered it already, but on the off chance you know this one, right now it's not possible to catch Spring security exceptions in order to use the mapping Jackson converter to produce JSON output. Is there something in the works for Spring security to produce all the output in JSON, XML, etc.? On the off chance you happen to know that one, if not, we can pass that on to Rob or something.
I don't know actually. If you do intercept the I can take a swing at it. If you intercept the exception and you want to change that, you can actually create an exception handler somewhere in your code. And I'm not sure if the Spring security exceptions are caught by those, but if they are, then that's your ideal place to plug that in. Spring HATEOAS includes something called V&D errors, which is a nice way to convey errors back to the client in a useful, descriptive way. And at a minimum, there's a mapping of errors to status codes that you can, contribute to if you want. But the V&D errors is definitely the more elegant way. I'm not sure if that mechanism is handled by the same exception handler mechanism in Spring MVC, but I imagine it would be if it's just an exception. If it's an uncaught exception inside of Spring MVC, it should be caught by a Spring MVC exception handler, component.
Yep. Okay, I think last question, and then we're gonna have to shut it down. And I think we're kind of running out of time. We're almost at 11:30 here. Let's see. Yeah, we think, boy, Craig and Oliver really knocked him out. There's not much left.
Thank you, guys.
Yeah. There's one that I think might be just worth highlighting and repeating. Follow-up question from Vlad Gilinski. He wanted to get an opinion, and Craig already answered this, but I think it's worth repeating. He wanted to get an opinion on Backbone.js versus Knockout.js versus AngularJS or other JavaScript frameworks, and how they integrate with REST and Spring. And
most of them have. What did Craig say?
Oh, well, he was just saying his question mostly depends more on the JavaScript framework and how it works with REST.
Yeah.
Generally, they should work fine. He says he's used Backbone to consume Spring MVC REST endpoints. And with that said, you might want to take a look at the Cujo.js REST.js module, which is a library that's coming out from our Spring Source JavaScript team, which is going to be designed specifically for doing exactly that, consuming Spring REST and Java, RESTful services in JavaScript.
Yeah, plus one. I happen to know more about Angular.js. I've used it quite a bit and I quite like it, but that's just a component framework. It's a widget framework. You're still going to need a RESTful API, a RESTful client. Angular.js and Backbone.js both provide the ability to say I've got a entity type and that here's the base URL, and if it follows certain conventions, you can bind the entity type in the view, or you create a model rather on the client, and that model can, based on conventions, automatically hit RESTful endpoints on the server side. But again, it's up to you to make that RESTful API conform to that convention. Otherwise, you might want to use something a little bit more low level, like REST.js or jQuery's client or whatever. If you're looking for OAuth, REST.js includes an interceptor for OAuth, and obviously you can use something like JSO.js for OAuth as well.
Guys, thank you very much. I think we're at time. It's 11:29. We need to cut it at the half hour here. Thanks so much, everyone, for all your questions, your activity. Josh or Oliver, if you guys want to say anything in conclusion, please feel free to do so.
Oliver and Craig, thank you guys so much for hanging out, and everybody else, thanks for coming. Don't hesitate to reach all of us. Oliver Gierke on Twitter, and Habuma Habuma on Twitter as well for Craig. And I'm of course a Starbucks fan on Twitter, and we look forward to hearing from you. And hopefully you guys will come to Spring One in Santa Clara this year.
Yep, September 9th through 12th. Get to meet all of us in person. Thanks so much, everyone. And later this month, we've got some other exciting webinars coming up. So if you go to springsource.org, you can see what we've got else in the lineup. John Brisbane is going to be talking about Reactor, which is a new sort of asynchronous event dispatching processing framework on top of the JVM. It's going to be introducing that. It's going to be pretty exciting. And then a little bit of a different webinar than the usual. We're going to have a guest speaker from Liberty University kind of talking about some of the soft skills around how to, organizational concepts, how to basically help the rest of your developer organization, consider adopting things like Spring. And those are both coming up later in the month. June 18th for the Reactor webinar, and June 27th for the Resistance is Not Futile, How to Talk Spring and Influence People webinar. Should be fun. So hope to see you there. Thanks a lot, everyone. And YouTube will have the replay.